Now, punta na tayo dun sa machine learning na aspect. Okay, so this is a basic linear regression na command, tawag dito, para malaman kung ano yung x at kung ano yung slope at saka yung y-intercept. Okay, so kung hindi niyo yan naintindihan ngayon, it's totally fine kasi explain ko naman yan in the future meetings. Okay? Um, Basically, ang meron lang dito ay meron kang layers. Okay? Pero in this case, isa lang yung layer mo. Okay? Which connects yung input to the output. Okay? And then meron kang training options kasi you are training the computer to learn about the data set and to figure out the patterns. Yung training options has the following options. Okay? So, ito is an optimizer. Okay, this is stochastic gradient descent with momentum. Okay, i-explain ko din yan in the future classes, in the future courses. Meron ding option na max epochs. Okay, which is here I set it to 100. Basically, pag sinabi mong epoch, is just one cycle. Okay, one learning cycle ng computer. Merong initial learn rate. Mamaya i-explain ko kung ano ito. And then, plots kung gusto mong ipa-plot yung training progress or hindi. So, balik tayo dito sa SGDM. So, you've heard dito yung term na gradient descent. Okay. Of course, the full term here is stochastic gradient descent with a momentum, but here there's this term which is gradient descent. So it's using basically yung gradient descent method to minimize the error. Okay, so ang nangyayari dito is aalamin ng computer kung ano yung pattern. Pero for the computer to know what is happening, manghuhula muna siya. Sabihin niya, okay, ang first na hula ko ay ang slope is ganito at ang y-intercept ganito. Ipa-plot niya ngayon yan against the dataset. Tapos i-compute niya yung error. Gaano kalaking error yung makukuha niya. Okay, makikita niya, uy, malaki yung error. Okay, mag-a-adjust ako. Pero hindi siya mag-a-adjust randomly, di ba? Mag-a-adjust siya based on the gradient descent method. Okay, so yung adjustment niya is mathematical. The gradient descent will tell the computer kung aling direction siya mag-shift. Now, gradient descent method or stochastic gradient descent method is one of the many optimizers na pwede nyong gamitin. And i-discuss din natin yan in the future sessions. In Python, ang isa sa mga ginagamitan o isa sa mga classes na ginagamit para sa machine learning ay itong TensorFlow. And you use this Keras na class para mag-define ng layers, mag-define ng training options, mag-define ng optimizers, and so on and so forth. Okay, so dito, gumamit lang tayo ng isang layer and makikita natin yan dyan dito sa units. So this is just one unit layer. Okay, one layer lang. Okay, with an input shape of 1 kasi isang data point lang siya. Okay, isang data point per learning lang yung inaaral niya. Okay. Okay, and then ito din sinasabi lang natin dito kung anong klaseng tawag dito, kung anong gagawin, kung anong klaseng layers yung gagawin dito. So it's a sequential layer. And then makikita nyo rin dito sa compile na command yung options. Optimizer is stochastic gradient descent. And then dito dinedefine niya kung paano niya i-present sa inyo, kung ano i-compute niya para malaman kung accurate or hindi. Dito, ang kinocompute niya rito is yung loss. Yung loss is computed by taking the mean squared error of the data set. There are other ways to present yung error. Okay, so may loss, may accuracy, and then may root mean square error, and so on and so forth. Okay, so di-discuss ko din yan in the future. The next step, after nyo ma-define yung layers, okay, yung sequential layer at saka yung options, is to train the network. So ito yung command sa MATLAB to train the network. Train network, ang input is yung X dataset, yung Y dataset, yung layers na dinefine dito, at yung options na dinefine dito. Now, yung training, okay, you place the training in a variable called net. So, ito yung model, training model natin yan. Ito yung pangalan ng training model. In Python, okay, ilalagay natin yung, i-train natin itong model by using the fit command. Gusto lang natin kasi linear regression ng time. So, gusto lang natin i-fit yung x at saka y. And then we're going to do that for 100 epochs. Dito yung number of epochs nakalagay dito sa fit sa Python. Pero dito sa MATLAB, yung number of epochs ay nakalagay dito sa training options. Itong verbose, ang ibig sabihin lang nito is kung gusto mong i-present yung output per epoch. Okay, it's quite similar to sa MATLAB dito sa plots. Okay, makikita niyo rin yan mamaya when we run the code. Okay, so this is not the name of the training model. This is just a default variable kung saan ilalagay natin yung parameters ng training. Okay, so dito ipapakita natin yung loss, okay, as a function of the number of epochs. And then ito ay mga titles, labels lang ng plots, and so on and so forth. Okay, now, actually, ang pangalan ng model natin dito sa Python is model. Okay, of course, pwede kayong gumamit ng iba rito na pangalan, okay, pero mas straightforward kung nakalagay na model kasi alam mo kaagad yun yung pangalan ng model, di ba? So we use the command predict. Okay, if we want to test kung tama yung nangyayari, we use the command predict, okay, para malaman kung ano yung output, okay, nung na-predict niya. Okay, so then i-compare natin ngayon yung na-predict niya, x tsaka y mac, and then yung dataset, tignan natin kung pareho yung magiging result. Okay, yun yung nakita nyo kanina, layers, yung training options, at saka yung pag-train. Okay, remember, yung option na plots, ang ipa-plot niya dito is yung training progress. And you'll see the training progress when I run this code. So run ko itong section na ito ngayon. Kasi ito yung mga training options. Okay. Dito. Okay. First of all, generate siya nitong training, iba't ibang training options. Now, ang dinefine lang natin na training options dito ay itong stochastic gradient descent with momentum, max epochs initial learning rate, tsaka plots. But there are in fact maraming options. Yung momentum, learning rate epochs, learn rate schedule, drop factor, drop period, and so on and so forth. Lahat yan matututunan nyo in the future classes, future courses. Okay, now when we train, okay, we use this command train network and it will output itong tawag dito, itong table na ito. For the first epoch, okay, nag-lap siya for 3 seconds at yung loss niya is 3.8. Okay, 3.8. Okay, yung root mean square loss niya is 2.76. Okay, huwag niyo muna pansinin yung term na mini-batch. Explain ko din yan later in a later course. Okay, and then after 100 epochs, 100 iterations, okay, bumaba na yung kanyang training, tawag yung kanyang loss from 3.8 to 0.1, yung root mean square from 2.76 to 0.51. This is what you want. Gusto mo na bumababa yung training loss. Okay? If you graph that, and again, this graph will only be shown if this option is turned on. Pag hindi mo nilagay yan, hindi lilitaw itong graph na ito. Okay, so, ano nakikita natin dito? Dalawang nakikita natin dito, yung root mean square at saka yung loss. Okay, so merong, yung root mean square has these actually two curves. Makikita nyo naman dito, yung actual training is this light blue, pero yung smooth out is itong dark blue. Then, ganun din dito. But in any case, makikita nyo na yung shape niya is baba, akyat, baba, akyat, baba, akyat. And then saka siya mag-smooth out. Okay, in fact, after 60 iterations, pwede na yung training model. Okay, so you can go back Okay, and then change the number of epochs to 60, okay, para mabawasan yung training time. For now, hindi siya ganun ka-significant kasi kung titignan niyo 6 seconds lang nag-run yung ano na to, yung training ano na to, di ba? Yung training. Okay, but in the future, when you have a lot of dataset, especially kung figures yung dataset nyo, your training will be from minutes to hours to days, depending sa dataset. Okay, then the number of epochs will be important. Okay, and you will base the number of epochs from this training progress. Okay, that's why it's important to turn on the plotting option para sa training option, training progress. Okay, i-predict muna natin yung ano. So, i-predict natin kung anong lalabas. Pag ginawa natin yan, we do this, and we have this, tawag dito, equation of the line. Okay? Makikita natin na maganda rin yung fit, di ba? Nung line with the dataset. So, if you want to see kung ano yung slope at saka y-intercept, you can use, so remember na yung pangalan ng model is net, di ba, sa MATLAB. So you can use this command net.layers kasi layers, okay, pag nakakita kayo ng ganitong dot, ibig sabihin ito lang layers is an attribute of the model net. Net.layers, yung command lang na ilalagay nyo. Okay, and then i-type nyo 2, 1 at ito yung mga lalabas. Okay. Ang hyperparameters, input size is 0, 1, tsaka output size is 1. Okay, di-discuss ko kung ano yan. Hyperparameters later. But yung learnable parameters ay ito. Yung weights is 2.0227, which is very near dun sa slope na 2. At yung bias is 0.4173, which is also quite near dun sa 0.5. Okay, if we continue further, ito yung P na nakuha natin from the built-in polyfit function ng MATLAB. Okay, at using the polyfit function, yung mean squared error is 4.0499. Okay, so sa Python, ito yung command. Okay, so this is exactly the same command as kung ano nakita nyo sa slides. Okay, dense layer unit, yung sequential training options, and then yung fit, and then yung plotting. Okay, now dito pinlot yung model loss. At kung titignan nyo, hindi siya katulad nung sa MATLAB na umaakyat baba. Di ba? Medyo straightforward siya na biglang bagsak. So, ibig sabihin dito, after siguro 20 iterations, pwede na siya. Okay. By the way, dito sinet yung verbose as 0. Let's change this and tignan natin kung ano mangyayari. So, pag naka 1 yung verbose, makikita nyo na ngayon yung training progress. Yan. Ito. So, makikita nyo kung ano nangyayari sa loss niya, okay, per epoch. Okay, so for the first epoch, ito yung loss niya, 8.6. And then pagdating niya sa tawag dito, sa epoch 100, ito yung training loss niya, 0.013. Okay, again, kaya nyo lang nakita itong, kasi sinet lang natin itong verbose from 0 to 1. Pag 0, hindi nyo makikita yan. Pag 1, makikita nyo yung training option na to. Okay. Then, nandito yung model loss. Okay, so let's get the weights. Okay, let's get the slope at yung y-intercept. Okay, so dito yung slope is 1.9845. So it's very close to 2. Diba? At dito naman, yung y-intercept is 0.51654442. So it's also very close to 0.5. And if we test it, make a prediction, 3, for example, we say ang data point natin is 3, ang mapipredict niyang value is 6.5. Okay, so alam naman natin kung gaano kalaki yung error na yan, kasi na-compute natin from this, okay, from the loss. Okay, pwede rin natin i-compute dito. Okay, so yung error is 6.5%. Okay? So akala natin akala ba natin ay ang tawag dito, magaling yung computer supposedly na mag-predict, okay, o na matutunan itong mga bagay na ito. Okay, well, remember that we are using statistical methods. How good the machine solves for or predicts the result will depend on yung statistical method na ginamit dun sa code. Okay? Generally, it's all statistics. Okay? So, it's all probability. So, what we're saying here is that yung probability according to the computer, okay, or according to the statistical code, na yung slope ay ganitong value, okay, 2.0227, at yung probability na yung bias ay merong ganitong value, 0.4173. So, hindi siya exact talaga. And ganun din yung mangyayari later pag diniscuss natin yung classification. Pag nag-classify tayo ng halimbawa dog versus cat, hindi sabihin sa iyo ng computer na, okay, sigurado ako dog yan. Sigurado ako na cat to. Okay, tayo alam natin, oh, aso yan. Okay, and 100% certainty na ito ay pusa. Okay. So, sa machine learning, sasabihin sa inyo ng computer kung ilang percent sa tingin niya yan ay aso. At ilang percent sa tingin niya yan ay pusa. So, it's 95%, I'm 95% sure, okay, na yan ay aso. 95% accuracy yun. Okay. And ganun din, 95% sure or 93 or 97% sure na yan ay pusa. Okay, so ganun dinidescribe or ganun sasabihin sa atin ng computer yung kanyang learning. Okay? Okay. So, so ito na yung para sa comparison between ginagawa ng humans, kung paano natututo yung humans at kung paano natututo yung machine. And makikita nyo talaga yung big difference in terms of kung paano pinoprocess ng computer yung information versus sa kung paano natin as humans pinoprocess yung information. Okay, and merong malaking difference. Ang isa rin siguro sa mga objectives kung bakit gustong matutunan ng mga data scientists or mga computer scientists yung tawag dito statistical methods is gusto rin natin kasi maintindihan kung paano nag-work yung brain or trying to mimic as much as possible how the brain works. So we model it using itong mga statistical methods. And as far as modeling using all of these methods that we have now at the present is concerned, ang layo pa natin. Hindi pa natin, uh, we're sort of just touching the surface, trying to understand how the brain works. Okay, baka hindi pa natin tinatouch yung surface kasi we're nowhere close to how tawag dito, we think our brain works. Okay, second side note, so isa-send ko sa inyo yung video nito, isa-send ko sa inyo rin yung codes, di ba? And you will find the codes here. Okay, so in the future, if you're really interested in tawag dito, in pursuing data science or machine learning, becoming an artificial intelligence tawag dito expert, and you want to use these tools, for example, sa physics to do research or to develop more complicated softwares, okay, marami or karamihan ng mga scientists, data scientists, ay nilalagay yung kanilang codes dito sa repository na ito. Ang tawag dito is GitHub. Okay, github.com. So, dito nyo makikita ngayon yung mga codes. At kasi dito ko rin nilagay yung codes na ginagamit natin yan. So, for example, today, this is Intro to Machine Learning. I have these two codes here, Intro to Machine Learning.mlx. Okay, so i-click nyo yan. Hindi nyo makikita yung code kasi hindi na-recognize ng GitHub yung live script ng tawag dito ng MATLAB. Okay. Pero merong button dito to download the raw file. So you just click this at mag-download nyo na sa desktop niyo yung raw file para mapag-aralan. Then you open MATLAB. Okay, pagdating sa Python, you click this. Okay, and then you will see yung command nito. Okay, you will see the whole code. Okay, so nandiyan yan lahat. Okay, so if you're logged into your UP email account, you should be able to see this. So mapipreview nyo yung code. And then meron ito. Ayan o, may nakikita nyo yan, open in Colab. So pag in-open nyo yan in Colab, mag-open siya ng tawag dito, Google Colab na environment. Pwede nyo lang i-run ito, runtime, run all. Pwede nyo na i-run yan para makita, or pwede nyo i-run isa-isa. Pwede nyo i-save sa inyong drive, sa inyong tawag dito, Google Drive. So file, save a copy in your own Google Drive. Kung may GitHub kayo, pwede nyo na i-save sa GitHub. Okay, pwede nyo ring diretso na i-download. And then i-upload nyo later sa Google Colab or sa ang tawag dito, sa Python environment na ginagamit, Python API na ginagamit.